We have started recording. Yeah. So in our syllabus so far, we've come uh, three, four, five, one, and two, and we are left with these two models. We have six and seven. So today's this session is going to be module six. We'll give a brief introduction about everything, and then we can solve some questions. Okay. Let's begin. Okay. Module six. So the main things that are there in this module is the two protocols, the TCP and UDP. These are the two protocols, and along with this TCP and UDP, you're also going to learn quality of service, reliability, all that comes under quality of service, and you'll find out how we can use to how we can use these protocols to get quality of service. Okay, so to give you an introduction about TCP, TCP. TCP is what we call, I'll type it right, what we call a stream-oriented protocol. It means it is concerned about sending messages as a stream. Stream is like a continuous flow. That is what it means. And the main thing which you have to remember in TCP is that there's a protocol for connection establishment. And what is this protocol? This is what we call three-way handshaking. This is the single most important thing in TCP. So that's going to be our we'll talk about that in a little bit. Before that, what are the other topics that we'll have? We have something called a TCP header. We have this. So header includes all the segmenting, numbering, the options, everything that's available in there. Okay, so let's go ahead and quickly review what is three-way handshake. So I'm gonna write three-way handshaking. Three-way handshaking is a way where, in very simple terms, we have two nodes. Okay, there is one message called the SYN, then there is something that comes back called a SYN plus acknowledgement. So I'm just going to write SYN plus A, and an acknowledgement comes back. Oops, so that was supposed to be A. That's it. That is all that is in. That is the three-way handshake. So you have SYN message, SYN plus acknowledgement message, and and finally an acknowledgement message. And this is all based on something called ISM. Let me write that. That is the initial sequence number. So the packets are numbered based on something called ISM. And if you want to terminate this connection, this is for establishing. If you want to terminate this connection, you'll have to do all the three things again. Right? Then what do you have? Yeah. So yeah, so if you are, this is for establishment. If you are terminating, so let's write here establish. You want to terminate. You'll do a similar set of things. So you will send something called fin, and then you'll get back with the arrows. You get a fin, you'll have fin plus acknowledgement, and then finally you'll have last acknowledgement. And with this three-step procedure, you can destroy any connection, any TCP connection. Okay. Now we're going to see something about simplex and duplex. Simplex and duplex. I want to talk about duplex first because so what is the difference between simplex and duplex? Simplex means it's like telephone. Both can talk at the same time. Simplex is only one can talk in one direction, like radio. Radio, you cannot talk to the radio and communicate to the station. Only the station can talk to you through the radio. That's simplex. Duplex means both can talk. So when you're doing a duplex TCP, that's a three-way handshake. But for simplex TCP, what is different? You don't need this a simplest acknowledgement this way. You only need an acknowledgement. So in that case, it is just two-way. And what is that two ways? You'll have a SYN, then you'll receive an acknowledgement. That's it. Okay. And we have that's all about the handshaking. Now a question can come: what would happen if we don't have these? If you don't receive this acknowledgement, that let's say this acknowledgement, that means this node is saying that it rejects. It's not allowing that connection to be made. Maybe there is no available port or something. Okay. Now we're going to talk about buffers. Buffer. So I'll better type it. Buffer. There are two types of buffer: sending and receiving. RECEIH. Sending buffer is for a three-color buffer, and the receiving buffer is two-color buffer. What is color about this? Color is all about the categories. So when you're sending a message from one place to another, what are the categories of messages? Some messages are sent, some messages are not sent, and some messages are that have been sent and need to be saved on the disk. So three types: sent, not sent, to write. And if you're receiving a message, that message can fall only in two categories. That is, uh, to receive. So you have not yet received, you have not yet got it yet, and not read. You've received it, but you have not read it. Okay. Now we'll talk a little bit about the TCP header. So give me a minute. Let me write here header. Actually, I can do it on a new page. So TCP header. Hmm, okay, so these are the components that I need TCP header. We have seen headers before this in the when we are doing the other The other, when you're seeing IPv4, IPv6 servers, so this is a little, so you will have some familiarity with it. So you have, so quickly, let's quickly go through this. Source, you know what that is. Source from where it is going. Destination, where it needs to go. Sequence number, this is important. So sequence is in the sequence of TCP packages. Where does it fit? What is its number? Acknowledgement number. Yeah. Then you have these options. You have reserved flags, DO, window size, checksum, origin pointer, and some more options. Right. So that is TCP header. What are these options? What are these options identify? So in TCP header, you have certain things. So you can decide whether you want selective acknowledgement, what is the maximum segment size you want, what is the window scale that you window scale, the window size is outside. Yeah. So I'm just gonna write yes, selective acknowledgement, things like MSS. MSS is maximum segment size. Okay. Now sequence number, where is sequence here? Sequence number. The sequence number is special in TCP because sequence number in TCP is actually a start byte number plus a random number. So what is done is it uses a random number and then adds that to the start. And that would give you a TCP number. TCP sequence number is actually quite random. And the acknowledgement number. The acknowledgement number is something that you what is the next byte you expect for the acknowledgement. Okay. So that was about TCP. That is all about TCP. When we solve questions, you'll have a little bit more idea. Let's quickly move on to UDP. So UDP, the things that you have to remember. UDP, you have to remember it's connectionless. So none of the big handshaking connection less. None of the big handshaking thing and all that we saw in TCP. It's it uses it's unreliable. So since there's no connection, it's just being sent like just like that. That's why we say UDP is an unreliable connection protocol. What else? It is a process to process, the process to process connection. What does that mean? Normally, when we talk about kind of connection between two places, we talk about one device is connected to another device, whatever. But the thing is, these are two hosts. In process to process connection, the hosts are not connected. Instead, it's the process from here. Let's say some process is running here, and that is communicating all the way with another process that's in this. That is the way the TCP works. That's the way the UDP works. Sorry. So what happens if there's an error? And the answer is in UDP, if there's an error, just discard. There's no error correction thing that happens in UDP. And just discard, no need to inform source. So that means if something is lost, it's lost. is discarded. Source does not retransmit something that has an error. That is the unreliability part. So it is a small and fast protocol. What about the ports? UDP ports, the ports that is used in UDP, there should be an incoming port. That is what a port. So should have incoming port. So why do you need to have an incoming port? Because only then are you going to be able to accept all the messages that have been broadcasted to it. And one good question. If UDP has no error correction mechanism, how does it send retransmit messages? Or does it is it able to send retransmit messages at all in the whole protocol? The answer is actually yes, it does. It is able to, and it uses a protocol called yes, it uses something called ICMP. And using the ICMP protocol, the UDP can still send error messages. So retransit, please retransit. So next, so that's all about the ports. Then you also have to know about multiplexing and demultiplexing. So basically, multiplexing means uh so wait, let's draw a multiplex. If you've learned digital logic, you will know multiplexing is basically selection. Selection of cache. So you have four. Based on the value that's received here, one of these outward connections will be chosen. That is multiplex. And so how will multiple in UDP? How does multiplexing happen? Um, how can different processes? How can multiplexing happen in UDP? Basically, what I'm asking is different processes want to communicate from a device. How will they communicate? Because all of them, because if it's host, you can, there'll be a queue, you can go through the connection. But if it's process to process, how do you do it? And the answer is actually using ports. So different processes use different ports. And you would have seen this also when you're installing any program or running any program that requires ports. It'll say so and so program is running on this port, port 20, port 40, port 30. I think it got disconnected in between. Okay, so what I was talking about was ports. Yes, I said how ports, different processes use different ports so that they can get, they're able to communicate to each other. Okay, so now we're going to see about the UDP header. So if you give me a minute, let's put it in a new page. I let it load. Okay, so UDP header. So as the first thing you see when and you realize when you see this is actually very simple. There's nothing in this compared to like what we saw in the other ones, right? So just source port, destination port is a length bit, this is checksum bit. That's it. So it's a very short, you know, right? That's so, and it has because this not why is the header short? So it does not if it has a long header, then it won't be able to communicate fast. There'll always be that header overload. It doesn't want that. Okay, so let's also talk now a little bit about apps. What are the applications of UDP? And we're going to list a few applications. So first is DNS client. What is DNS client? Domain name service. You should already know DNS. So DNS it takes it. So let's write it here. Converts URL to IP. So if you're searching for some URLs like for example google.com, the DNS server will give you the correct IP address related to google.com. That's how you're able to get there. And DNS has to be fast. So we cannot have this very reliable flow communication using TCP. You need UDP. Okay. Next we have multimedia. What about multimedia? Multimedia, you mean like things like video conference. So let me write video conferencing. Video conferencing more important than reliability is speed. So let's say for example some package is being transferred. Somebody says hello and that didn't reach you quite well, and your host told the center to retransmit the hello. So imagine how much time would go when hello is not even the most important part of it's not the most important part of the conversation. So that's why multimedia prefers to use UDP connections. Okay, next TFTP. TFTP. What is TFTP? TFTP stands for Trivial FTP. FTP you should know is File Transfer Protocol. Trivial FTP means what? It's some trivial data, some maybe some error control, not important, trivial matters. When something not important, not as important as a pop-up data package is sent, you don't need to use TCP and all the headers and everything. We want to save time. Hence, we use um, UDP. Then we have something called multicasting. We saw a lot of questions on this in one of the previous sessions. Multicasting is you're sending to a group, not broadcasting. Instead of sending to everyone, you're sending to everyone in one particular group. Again, you're sending a lot of people. UDP is better than TCP. And finally, routing. For example, when using an algorithm like routing information protocol, RIP, or something similar, you need to be able to see, like, you need to be able to update the routes that the package is taking quickly. And those tables in the routers that have the identifier for the routes, they need to be updated fast. That's why we use UDP. These are UDP apps. So you might wonder, oh, do we always use only UDP? Do we not use TCP also? We do use TCP. And one important thing is in FTP. FTP is file transfer protocol. Important to use in file transfer because you want to save your files. If you're moving your files from one place to another, let's say you're copying it from your desktop to your USB, you want the files to end up on the USB. You don't want to lose those files. So that's why it's important. It's even if you have to wait for a little bit, it's okay. It's not as bad as not getting a file. And second important one is email. Again, same thing. Even if there's a delay in email, it's okay as long as you get the correct message. Because in email, the content is quite important. You would rather have a proper email, one that has no errors, than to get something fast and bundled. Okay, let's quickly move on. Now we're going to see something called congestion control. So there's many types of congestion control in TCP. So UDP so UDP does not have these kind of control measures, but TCP does. So we're going to quickly see all the congestion control. We're going to list them out. Quickly finish this. So congestion control. I'm just going to list out everything first. So you have slow start, which we'll discuss. You have congestion avoidance, avoidance, and congestion detection. So congestion detection and avoidance should be quite clear. So you're detecting that congestion is there, or you're avoiding the congestion from being there. What is different is slow start. What is slow start? That's something that's something that we can do. So slow start. What are they talking about start? They're talking about the window size, right? Window size. And window size is something that if it's too big, it may cause a lot of congestion because bigger the window size, that much data you're allowing to be passed. So what it will do is in slow start, here's the algorithm. So start window size at 1 MSS. What is MSS? Maximum segment size. And then increase window size. So window size for every what is ACK? Acknowledgement. So it'll slowly so what you'll get is you get a linear um increase. It's gonna keep increasing one. And this will continue till you get three continuous acts. So once you get three acts in succession, you start so you reduce window size to half and start editing. So what do you mean is increasing the window size slowly one, and then when you get to three acts, reduced by half, and then you start the addition process of the window acknowledgement. Okay, let me see if there's a. So here's a good example. So you can see how start, 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 start. Then here's the threshold that they have. Then you're waiting for those three acknowledgements. So how many other acknowledgements? And then it's reduced to half. So you can see this drop. And then, oh, sorry. So not this. So let's. So you have here, you have slow start all the way till here, and after that you have additive. And so what happens here? What is this drop? This drop is actually when there's too much congestion. So you have something called congestion window also. So when congestion is too much, what the current, the window size will drop, the threshold will drop, and again slow start will start from there. So this is basically congestion avoidance with slow start. Then finally, what we have is going queuing and QoS. QoS is standing for quality of service. Quality of service is things like reliability, traffic shaping, designing, defining. So let's just list all of these things here. Quality of service. So the parameters that you have in quality of service, parameters, we have discussed this actually previously also, but remembering that reliability is a big thing in this transport layer, reliability, and also how much delay and how much jitter and bandwidth. These are all important things in the parameters that you say whether this is good quality or not. And another thing is traffic shaping. What is traffic shaping? So you have the traffic of messages, right? And for each message, uh, wait, when you have traffic shaping, what this is saying is, for example, if you see traffic, let's say at 7 a.m., there are a lot of cars. Let me, the road, car, 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 lot of traffic. But let's say at 7, just after, let's say school has started or whatever, 7, 5, there's no traffic. So this is 7:05. So what if we could do in such a way that 7 to 7:05, 7 all the way to 7:05, instead of having these three and then one, we could shape the traffic such that here there's moderate amount of traffic and here also there's moderate. That is what traffic shaping is. So in terms of networking, what would happen is you would have something called a leaky bucket. So I'm just going to write LB leaky bucket. The leaky bucket protocol, we have a bucket. You won't actually have a bucket, but symbolizes a bucket, and there's a I thought that would be white, but so what I mean to say is there's a bucket with a hole, and how much water is filled in that bucket, this that is dripping out will be in a constant rate. So sometimes the bucket will be full, so much congestion, but still the hole will be in that constant rate. These will be same whether the bucket is full or whether the bucket is empty. So so traffic shaping is when the messages that are coming, put them in the bucket. Sometimes you'll have just one message coming in. Sometimes you'll have a lot of messages coming. But whatever the congestion coming from networks, the the rate at which messages leave out of the bucket is the same. That is a leaky bucket algorithm. And traffic shaping is something that is part of QoS parameters. They are part of the quality of results. You can also change this, give a variation of this. So a variation if priority. And let's say there's some message that is high priority message. Then you should not be waiting in the bucket for very long. Right? We need to send it out. So those messages can be assigned a priority, and that can, and then when we're transferring outside the bucket, the priority message can be transferred first. Okay, so this is module 6. You have differences between TCP and UDP. What is the handshaking, bufferings? We saw the TCP header. Similarly, we went to UDP, how it's different from TCP, and how it errors and ports and how processes. Then we saw how simple UDP header is, where UDP and TCP is used, the applications of it. Then we saw congestion control. We saw slow start congestion avoidance, slow start, then the congestion avoidance, and the congestion detection. When a congestion is detected, the window rate will fall, and then again slow start will start. And then finally we saw QoS parameters. These parameters, as well as we understood what is leaky bucket algorithm. Okay, that's all this session. Next session, what we'll do? Next session will be exercises. So we're going to solve exercises related to TCP and UDP. Okay, that's the end of the session. I'll see you in the next session.